Hello class, today we'll be learning how to solve algebraic expressions, and this is going to be a very important lesson because this is the necessary step required to learn to be able how to graph properly and to do many other problems in algebra and algebra 2 in the future. So it is a very important lesson to pay attention to. So what is an algebraic expression? So when we look at the word algebraic expression, it can be broken down into two words. So the first word is algebraic, where we have the word algebra, and the second word is expression, where we have the word express. Now, you may have heard something when a teacher or something tells you to express yourself. That means to show or to tell how you are. And it's the same way in mathematics. So when we talk about an expression in mathematics is any mathematical statement. So it's just a thing that they are telling us in math. So, for example, we have 5x plus 2, 7, parentheses, 2 plus 2, or 6 minus 9. These are all examples of expressions, okay? Now, an algebraic expression is any expression which includes a variable. So as we see here, we have 8y minus 3 plus 3y minus 6. Here, the y is a variable, okay? In the second example, we have x plus 4 over y plus 3. In the second example, both x and y are variables. And in question number 3, we have b. Now, b is also an algebraic expression because there is the variable, which is b. Now, so an algebraic expression is just a mathematical statement that includes a variable. Now, this is different from an algebraic equation that you may have heard of. Now, an equation is something that has an equal sign. As you can see in these three problems, there is no equal sign. All it is saying is a statement. This is saying, for example, b. That is the only statement that it is making. So this is an example of an algebraic expression. Okay, so let's look at algebraic expressions and break them down. So here we have the algebraic expression 2x plus 4. Now here in the expression 2x plus 4, we have two terms. We have 2x and we also have 4. Now let's look at 2x because this is what makes it an algebraic expression because we have the x here, which is a variable. The number in front of a variable is called a coefficient, and this will be important. Okay, so let's go over this again. We have an algebraic expression 2x plus 4, and in this we have two terms. We have 2x and we have 4. These are not like terms because they have a different variable. As we can see here, we have the variable x, while the number 4 doesn't have any variable, so they are two different terms. If we have the same terms, for example, if we had 2x and another 4x, for example, in that example, we have x's in both those terms, so we can combine them and put them together and simplify. We will go over this in the next part of the presentation. So we're going to go over simplifying algebraic expressions because this is one of the first things that we need to do once we have an algebraic expression. So the thing that we have to do that we previously mentioned is to combine like terms. So remember, combining like terms means combining variables that look exactly the same. So if we have 4x and 3x, we can combine them to make 7x because the variables are the same. They both have the variable x, okay? And we can also, after that, we can combine numbers. Now remember, we can always combine numbers. We can do 4 plus 4, 4 minus 3, 5 plus 5, because they are like terms. They both don't have any variables, so we can always add them. If you get confused about combining variables that look exactly the same, what I want you to do is think about it like this. For example, you cannot add 3 apples and 3 oranges because they are two different fruits, okay? You cannot say you have 6 apple oranges, right? You can only add apples with apples and oranges with oranges. And this is the same with variables. You cannot add 3 plus x because they are not the same thing, right? But we can add x and x, and we can add 3 and 5 because they have the same variable. Okay, so let's look at the first problem here. So we have the first problem, 8y minus 3 plus 3y minus 6. Okay, so I'm going to give you some time to work on this problem, and we'll go over the answers together. Okay, so we have 8y minus 3 plus 3y minus 6. So like I said, the first thing you should have done is you should have combined like terms, right? So here we have highlighted, we have 8y and 3y. These are like terms because they have the same variable y, okay? We can also combine negative 3 and negative 6 because they also have like terms. They have no variable, they're both numbers, so they can be combined, okay? So that would give us the answer 11y minus 9 because 8 plus 3y is equal to 11 and negative 3 minus 6 is equal to negative 9. So let's move on to the second question. In the second question, we have x squared plus x minus 4 plus y minus 2y. So this may be a little complicated, but I assure you it is not. You just have to follow the same steps as before, right? So I'm going to give you some time again to think about it, and we'll go over the problem together. Okay, so we have x squared plus x minus 4 plus y minus 2y, and what you should have done is combine like terms, okay? So what you should have done is combine the two like terms, which were y minus 2y, okay? Now, some of you may be asking, why can't we combine x squared plus x? Aren't this the same thing? And the answer is no. You cannot combine x squared and x because remember, at the beginning we said we can combine like terms that are exactly the same. X squared and x, the variables are not the same. The coefficients are the same. They both have the coefficient of 1x squared plus 1x, but the variable is not exactly the same. This is x while this is x squared. This is very important, so I want you guys to remember this, okay? So we have x squared plus x minus 4 plus y minus 2y. So we combine like terms, y minus 2y is negative y, so we get the answer x squared plus x minus y minus 4. Alright, so let's move on to the next problem. So in the next problem we have 2 multiplied by a squared plus 2b cubed plus 3c minus b cubed plus 3a squared. Now this may look intimidating, but it is yet again the same as the very first problem that we did, and you just have to follow the steps of combining like terms and then simplifying. For this question, I really want to encourage you to remember your order of operations so that you get the question correct. I'll give you a couple of seconds and then we'll go over the question yet again. Alright, so for this problem, you want to first distribute the coefficient, but let's look at the problem as a whole. So I was saying that you want to use the order of operations, so let's remind ourselves what the order of operations is. It is, the way we remember is using the acronym PEDMAS, right? So we have parentheses, exponents, divide, multiply, add, and subtract. Okay, so let's look inside the parentheses first. We have a squared plus 2b cubed plus 3c. We cannot combine any like terms here. Then we look at this inside these parentheses, b cubed plus 3a squared. There are no like terms we can combine there either. Next, we want to look at exponents. We have exponents, but they have already been distributed, so there's nothing to do here. Now, the next step is to look at dividing and multiplying. And that is something that we can do since we have this 2 that has to be distributed and this negative 1 that has to be distributed. So once we distribute this, we would get 2a squared, because we do 2 multiplied by a squared. Then we get 4b cubed, right? And we would get 6c. And then we want to distribute this negative 1, so we get negative 1 times b cubed, which would give us negative b cubed. then we would do -1 multiplied by 3a squared, which would give us -3a squared. After we have done that and we have the expanded algebraic expression, what we want to do is then combine like terms. So we have 2a squared and -3a squared, which we can combine to form -a squared. And then we can combine the like terms 4b cubed and -b cubed to give us the variable of 3b cubed. And finally, 6c does not have a like term, so we just leave it as itself. And we get the answer, -a squared plus 3b cubed plus 6c. Okay, so let's go over evaluating algebraic expressions. So we talked about how all algebraic expressions must include a variable. And we said that it is called a variable because it is a symbol that represents a number. And the number that it represents can vary, which means it can change. So when we are evaluating algebraic expressions, what we are doing is we are plugging in a number for that variable. So for example, we have 4x plus 4, and we are saying when x equals 3, what does 4x plus 4 represent? What is that expression? Remember, the expression is a mathematical statement. So what is the statement 4x plus 4 making when the variable x equals 3? So all we do here is whenever we see x, we want to replace the variable x with the number 3. So here we have 4, a parentheses 3. We are putting in 3 because we are saying that x equals 3. So we are replacing this x with 3. So we do 4, a parentheses 3 plus 4. So we would do 4 multiplied by 3 is equal to 12 plus 4 equals 16. So we know that when the algebraic expression of 4x plus 4 when x equals 3 equals 16. Please rewatch this section of the video because I understand that it can be a little confusing. But if you understand, let's move on to the next problem. So we have another problem similar to the last one. I want you to simplify the algebraic expression, and then we want to do the new piece, which is evaluating the expression when a equals 1 and x equals 2. So remember, for this, what you want to do is first simplify and then make a equal to 1 and x equal to 2. I'll give you some time to figure out this problem. Alright, so for this problem, what we want to do is we want to first distribute the 3 and the -2. So we want to first distribute the 3 to the a squared, which will give us 3a squared, 3 multiplied by x squared, which would give us 3x squared, and 3 multiplied by 4, which give us 12. For this section, we want to make sure we are distributing -2, not just 2. So we want to do -2 multiplied by a squared, which gives us -2a squared, -2 multiplied by -x squared, which will give us +2x squared, and -2 multiplied by 2, which would give us -4. And then what we want to do is combine like terms. So we see we have the variable a squared here and the variable a squared here, so we can combine these like terms. We have x squared here and x squared here, so we can combine these two like terms. And we have 12 and -4 here, which are also like terms, so we can combine these like terms. When we do this, we should get a squared, because 3a squared minus 2a squared is a squared, plus 5x squared, 3x squared plus 2x squared is 5x squared, and 8 as 12 minus 4 is 8. Once we get here, when we get a squared plus 5x squared plus 8, what we want to then do is we want to evaluate. So we said a equals 1 and x equals 2. So remember, we want to replace a with this number 1 and replace x with 2. So when we do that, we say 1 squared plus 5 times 2 squared plus 8. And then we want to simplify. So when we are simplifying, you should get 1 plus 20 plus 8. Now the thing I want you to be careful here is the order of operations. Remember, with this one, we want to do 2 squared first, since it is parentheses exponent multiplication. So we want to do the exponent here first, 2 squared, which would give us 4. So we do 4 times 5, which equals 20. So we can say that when when we are evaluating for a equals 1 and x equals 2, we get our answer of 29. If you manage to get this answer correctly, you should be really proud of yourself since it was a pretty hard question. And there's going to be more problems like this in the homework in the Google Classroom, so feel free to check that out. Remember, this is going to be key for your competencies because in order to graph these problems in the future, you're going to be able to you're going to need to be able to do these algebraic expressions in the future. And this skill will be key for 8th grade and also for 9th grade, 10th grade, and all the other math classes moving forward. So if you have any questions, please make sure to email Bola or I, and please check out the Google Classroom. Thank you.